Hello everyone. This is a data structure class and my name is JoonsooBae. So today we will go into 3.5 sections, mazing problems. This is a typical example of stack applications. Okay, in order to solve this maze problem, we must apply stack data structures. So this one, maze, do you understand what is maze problems? So that is very difficult, very complex cave, complex cave in the just like Egypt pyramid. Okay, it's very hard to find the true path from the entrance to the exit. Okay, clearly there is one entrance and exit. Okay, the problem is that we must find one through path for travel all of the through paths from entrance to the exit is amazing problems. So in real world, in order to solve the major problem, we must touch the wall. So we cannot cross or pass the wall. Okay, if there is a wall in front of me, then we cannot go in that directions. We must change the directions. Okay, so we must model the wall or the path in the maze systematically. So we will introduce number one as wall or blocked path in that directions, and the 0 means that it is a through path. Through path means that we can go this path. Okay, so if we see this major problem, 0, 1 means that entrance, it is of course 0 means that it is a through path. It is not blocked. But if we go to all the way, it is blocked because it is 1 means that there is a wall. We cannot cross it. But if we if we turn the directions downward, okay, there is a 0. We can go these directions. But we cannot go these directions. And also we cannot go outside of the boundary. Or we cannot go back this direction because this is outside or entrance. Okay? And then we will find this direction. Okay, this is good here. And also, so if we must search a possible direction systematically here. So if we are here, then we must find directions for the north, for the upward first, but it is blocked. And turn the directions here. Okay, it is good. It is a through path. And also here we can find a possible direction. Then it is outside, so we cannot go outside. And this direction is also outside, no. And this one, how about this one? This one is good. Okay, And also at this point, we will find this direction. No. Oh, this one is okay. So this one is okay. Now, and how about this one? No. This one, no. This one, no. This one, no. This one, no. But this one is okay. Yes, this one. And how about this one? This one, at this point, we will search directions, possible directions, this one. But this is already, we marked, we passed. Okay, so we cannot go back this one. So we will continue to find. Also, this is also already visited point. And the next one is this one, no. This one, okay, this is good. So we will follow these lines. And at this point, this one, no. This one, no. This one is possible. And how about this one? This one is good. Okay, in this way, we will search every possible point. Okay, this direction first. And this direction first. This direction first. No, this is end point. Okay, there is no possible directions except backtracking. Okay, so at this point we will backtrack. Oh, I will change the color. Okay, blue color as backtracking here. So you will backtrack here, and there is no possible way to again backtracking. At this point, we will continue to find at this point we will find this possible way, and at this point we will find this way, but this is also end point. There is no possible through path, so we will go back again here. So we will go back here from here to this one, and also at this point we cannot go back. So this one, no. This one, no. This one, no. This is all the way backtracking to the first possible point. Okay, at this point we found another possible path. Okay, at this point we will continue this one, this one, this one, this one. Oh no, at this point it is also end blocked one, so we must try backtracking. So here backtrack, 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 and backtrack, backtrack. Okay, here, okay, we will follow another way, these directions. Okay, so here we will continue, go forward, not backtrack. This one, and here we cannot go back here, so we will follow this line, and this line, and this line, and this line, and this direction first. Okay, in this way we will find successful through paths. Okay, this direction, this direction, this direction, this direction, this direction, and this direction is the first, and then goes here, here, and here first, here, and here, 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 here. Oh, okay. I will. Okay, I'm sorry. This is not. Okay, this one is correct one, and then this one. This is incorrect, and then this one, and finally we arrived at the exit here. Okay, so you can see very complex path. There is some backtracking in blue color and forward direction in red colors. Okay, and also we apply the very systematic search possible paths. That is very systematic. So we must search possible direction from the north, and then going, turn the directions. Okay, that is very systematic. So we can model that systematic searching in next slide. Okay, this one is a possible movers or allowable movers at the current positions. This is a current position. Now I am here in the maze. Now we can go to north direction, northeast direction, and east direction, southeast, south direction, and southwest, west, northwest. So there is 1, 2, 3, 4, 5, 6, 7, 8 possible directions. Okay, and also if I am at the row comma column position at the moment, if we go to north direction, then row value will be decreased by 1, but column does not change it. How about northeast? Northeast will have row value will be decreased by 1, but column value will be increased by 1. Okay, so you must be careful, focus on these values. Current location is row comma col position now, but if we go to northeast, we must change the row value and column values. And the east direction means that row value is not changed, but column value is increased by 1. And southeast row value is increased by 1, and column value is also increased by 1. In this way, we can control the possible direction by this number. This is a 0, and -1 plus 1, -1 0, -1 -1, -1 0, -1 plus 1, 0 plus 1, plus 1 plus 1. Okay, so every 8 direction has different value of these values. Row and column change values. Okay, using this one, we can model the possible directions. Okay, so let's go on. So now possible direction can be modeled using -1 0. the change of row and column values. So north direction is changing at the row values. Row value is decreased by 1, okay, -1. And horizontal means column value does not change at the north directions. Do you agree? Do you agree? Yes. And also northeast direction will change row value -1 and the column value +1. Okay, and east will not change the row values, only change at the column value +1. Okay, in this way, every 8 possible direction can be defined or defined as these values, change values, +1, +1, +1, and this one plus. And south is changing only row values, so +1, and the column does not change here. And southwest will +1, -1, and west means that it does not change at the row value, but column value decreased by 1, -1. And northwest is changing -1, -1. Okay. Furthermore, we will define as move values, move array. So move array 8 will be defined, which has two attributes, vertical and horizontal values. Vertical means that row value, and the horizontal value means that it is a column value. So we can define move array, which has two components, vertical and horizontal values. That is offset. Structure defined here. Structure, the name of this structure is offset. Okay, this offset has 8 member of array of movers for each directions. So this movers 8 array means that possible directions, 8 possible directions at the current position of maze. Okay, so it's a very systematic models of mazing problems now. So we introduced move array defined as this one, and we can calculate next row and the next column as row and column is current positions plus move this array, move values of this array. Okay, at this point, dir means the possible directions. 8 possible direction from 0 to 8. Okay, so if east is first possible direction, then we must add 0 values at the vertical or row value, but we must add value 1 to the column values. Okay, so we must move to the right. Okay, in this way, we can calculate next row and next column values using this offset array, offset move array. Okay, So this is a very clever design to represent the possible move or possible direction in the mazing problems. Okay, and now we will introduce new stack to keep the past history. Okay, we must keep the followed path until now. So that is past history. What path we kept until now. So that is used to store the past history is stack in this problems. So here we apply the stack data structure to keep past histories. Okay, so this path path will be stored in the stack array. And also this stack data type is user-defined structures, which has a row, column, direction component in this element. So one element stored in the stack has 3 components, row, column, directions. So that means that I am in 3,2 location, and also we will have 3. 3 means that this 3 means that row, and this 2 means that column, and this third component 3 means that directions 0, 1, 2, 3. Yes, that means that southeast. This 3 means that southeast. In this way, we will store the past history in stack. Why we must use a stack? That's because there is some endpoint. So if we meet the endpoint, we must go back or backtrack to the previous locations. In that situation, we must apply stack operations, pop. Okay, so that's the reason why we use a stack data structure to keep past history in mazing problems. Okay, we will go on now. So stack is used to keep past history. So here stack is initialized that mazes entrance coordinate. Yes, entrance coordinate is the first element stored in the stack. From this entrance, we will search every possible direction in the maze. So stack is not empty. The starting point of the search is north. Okay, move to the position at the top of a stack. So this row and column direction will be stored in the stack. And if we meet the possible direction to move, we will calculate next row and next columns. And dir means the direction of move. And the next row, next column is coordinate of location of next move. Okay, and we must search possible move from current positions. It will be looped. And next row, next column is okay. Also, we introduce mark array in order to distinguish this location is visited earlier or not. If it is visited earlier, we do not need to go there again. Okay, so in order to do that, we will use mark array also. And if it is successful, we will save current position and the directions to the top of the stack. Okay, so add a row, column, and direction element to the top of the stack. Also, we will calculate the next row and next column as current. So this row and column means that it is moved to the next row. Okay, so next row was calculated that we defined earlier. Okay, we can see the examples that applies the previous design in example amazing problems here. So here we can see the given maze here, which has 4 rows and 3 columns here. But be careful that this maze index start from 1, not zeros. Okay, every index in C language start from zeros, but in this example they used starting point 1, starting rows from starting index from 1, not zeros here. Anyone is okay, but this example uses 1 as the starting index of row and the columns here. And this one is entrance, and this one is exit. So we must find the through path from this entrance to this exit. Can you find it by your hand here? It is possible because this is a very simple example, but if maze is a large one, you cannot do it by your hand. So we can design it in the previous solution, and also we can implement it in computer programs. Okay. And now this is given problems, and we can start from this entrance. This entrance, okay, this is a starting point. So we must store this starting point in the stack. This is a stack array. Okay, and this is a mark array. Mark array. So 2 arrays are used in mazing problems, and this stack will use stack data structures. That means that there is pop and push operations. Push operation and pop operation will be used in stack array, but mark array is not stack. It's just a regular array. Okay, and this is a first locations, positions. Okay, so we will store this starting point 1, comma 1. This is a row, this is a column, and the directions that arrives this position 1 to 1. But can you see the direction of this one? I cannot see. I cannot understand what is direction that arrive to these zeros, these positions. I'm not sure, but this one will be used as a zeros. Just a zero. I cannot understand. The zero means it is a north, but at this point, zero is not has no meanings. Just a null, I think, because this is the initial values. And now, okay, so okay, now we are 1, 1, 0. This 0 has no meanings, no directions at the moment, because at the starting point there is no direction that drivers that drove this position directions. No direction is used because this is the initial point. If I am in 1.1 here, and now we must find the next positions from north, east. Okay, it is impossible because it is out of bound, out of boundaries. Okay, so we cannot go out. And now this one is 1 means it is blocked. It is a wall, so we cannot go. Now this one 0 is possible. Oh yes, 0. So this north direction is 0. North east is 1, east is 2, and this is 3. Okay, so now this one, I am in this position 2, 2. And what direction is used to drive us these positions? The direction was 3 directions. Okay, so we can store 2, 2, and the direction is 3. Okay, that is stored in stack data structures. This is a push. One push is used. Second push is used here to insert the history, past history. And also, we store 1, 1. 1, 1 is already visited. So we will store 1, 1 in mark array here. Okay, next one is okay. So now I am in this position 2, 2 now, and the direction used to make me arrive here is direction 3. So this 3 is stored here, and I am in 2, 2. So 2, 2 position is visited. So we will store at the mark array. This is a stack array. Okay, Now I am in 2, 2. We must continue to search the possible directions. North, no. Northeast, no. Okay, this one is possible. So 0, 1, 2 direction. 2 direction is possible. So the next point is 2, 3. 2, 3. And the direction used to arrive here is 2. And also we will store 2, 3 in mark array. I am in this position now. Okay, let's go on. Okay, so next step, I am in here. Here and 2, 3 and the direction was 1, 2, 3. Zero, 1, 2, 2. And 2, 3 will be stored here. Okay, so I am in here. Okay, 2, it's the same as 1. And next one, we will search possible directions from here. No, north is no. Outside, outside, and outside. This one, wall, no. This one, wall. This one, okay. This one is 0, but 2, 2 is stored in mark. That means that it is already visited. So we cannot go back here. It is not possible directions. So this one, no. So that means that this 2, 3 is endpoint. There is no possible path from here. Okay, so in that case, we must go back. We must go back to the previous positions. So this one, we must, previous one is here. So we must go back. Before we go back, we must, in order to go back in stack, this is a stack. Paint color. Yes, stack. This is operated in stack, and this is array. And in order to go back to 2.2, we must delete this past history from stack. How to do it? We must pop this one from the stack. That means that we will go back to the 2, 2 here. Okay, so the next one is that, okay, this one searching the possible direction, but no, that means that it is endpoint. So we will pop this 2.3, so it is deleted. If we delete or pop the 2, 3, that means that we are in 2, 2 now. 2, 2 now. And we will search possible direction again. Okay, no, no, and this one is possible. Okay, so here again we will store store 3, 1. And what is the direction that is used to this move? So 0, 1, 2, 3, 4, 5. Yes, 5 direction was used. So 3, 1, 5 will be stored. And also 3, 1 will be stored in the mark direction, mark arrays. Okay, yes, in this way, I am, okay, we'll continue. Okay, 3, 1 is current position now, 3, 1, 3, 1 here. At this point, we will continue to search the possible path. North, no. This one, 2, 2 is visited already, so we cannot go these directions. This one, no. How about this one? Yes, it is possible. So this position is 4, 2. And what is these directions? 0, 1, 2, 3. Yes, 3 direction is used. And also 4, 2 will be stored here. Okay, so that's the next stage. Yes, 4, 2, 3 is stored in here. And 4, 2 is stored in the mark array here also. And next one is this one. Okay, at this point we also search next one. North, no, no. This one, yes, it's possible. So that means that 4, 3, and what is the directions? 0, 1, 2. 2 is used. And this one, 4, 2 is mark array. Okay, that's the next element stored in stack. Okay, no. Yes, this one is yes. So 4, 3 is stored here, and the direction is 2, and the 4, 3 is here. Okay, now this one is final exit. Okay, using this one, can you find the successful through path from the entrance to the exit? Yes, if you follow this position, then it is possible through path in the maze problems. Okay, 1, 1 and 2, 2 and 3, 1 and 4, 2 and 4, 3. Okay, it is successful through path, and it is a solution of the major problems of these examples. Okay, yes. So can you answer how many push operation? Okay, this is a stack. How many push operation is used? Push operation, how many? And how many pop operation is used in the operations? So this one, this one, this one, this one, this one. 1, 2, 3, 4, 5. 5 push plus this location is stored here. Okay, so 6 push operation were used in order to solve this problem. And how many pop? One pop. This 2, 3 is popped. One operation. One pop operation is used in during this solution of these examples. Can you understand? Yes. So in here, this example used stack. data structure to store past history. Past history means that it is a solution of the major problems. Can you understand? Yes, that's good. So this shows another examples here. Another examples here. Okay, so this one is 4x4 major problems. Now 4x4 major problems. Okay, so this has a whole solution here. So this is also stack operation, and this is a mark here. So we will start from 1, 1, this location 1, 1, and it will go to this one, and 1, 2. This is no meaning, but this is a 0, 1, 2 directions. 2 direction is used here. And how about this one? At this point, we will search possible directions. No, 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 yes, this one. Okay, there is some errors here. So this is not. This is not. This direction comes first rather than these directions. So we will try this direction first. 2, 3, and what is the directions used? 0, 1, 2, 3. Yes, 3. This is also wrong one. 2, 3, this direction is here, stored here. And how about this one? 2, 4. Okay, this solution is totally false. 2, 4, and also 0, 1, 2 will be stored. 2, 4. Okay, this until this one it is okay. No. This 2, 2 is not visited yet. We must delete it. Okay, so this is a correct one. And how many push operation used? 1, 2, 3, 4. 4 push operation is used. Here. And then at the 2.4 location here, this is a end point because we cannot go to the north, outside, wall, and this is already visited. 2, 3 is here, and no. So that means that this is end point. Okay, so we cannot go back. We cannot go. So we must backtrack. Okay, I must change the color here. So blue color here, and we must go back to these positions. Okay, so before we go back, we must pop 2, 4 here from the stack. Okay, so 2, 4. Okay, I will stop here for this example because this solution has some errors, but this helps you to understand the major problems here. So I will add correct solution of this example problems again, okay, in the next slide. Okay. Okay, let's see the correct solution of previous example. This is example 2. Example 2 has 4 by 4 maze problems, and we use the same stack array to store the past history. So the first starting point is entrance. Here is a 1.1, and 0 has has no meanings. So this is the initial value, and this one 1.2 and direction 2 is stored here, and at this point this one 2.3 and direction was 3, 0, 1, 2, 3. Yes, this is a 3. And 1.1, 1.2, 2.3 is stored here. And next one is, okay, here 2.4 must be stored here. Okay, and what is the direction? 0, 1, 2. Yes, 2 is stored here. Okay, this one is stored at the moment now. 2.4 and 2.4 is also stored in mark. But at 2.4, there is no possible directions. 0, 1, no, 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 no. And this direction is impossible because 2.3 is already visited here. And this direction, no. So this is end point. At that time, we must go back or backtrack here. Before that, we must pop 2.4 from the stack. So the 2.4 were deleted from the stack. Now I am in here. 2.3. Yes, 2.3 is current position. So continue to search the possible path. No, no. Here, yes, it is possible. So next one is 3,2, and direction is that 0, 1, 2, 3, 4, 5. Yes, 5 is used. And 3.2 is stored in mark also. And I am in here now. From this one, we will search every possible move. Yes, there is also here. Okay, 0 is also possible directions. So, okay, it is not correct one here. So we must modify here again, and we must store 2.2 and direction 0 here after 3.2. But and the 2.2 will be stored in mark also. But this is a end point because there is no possible directions from 2.2. So we will pop this one also. So 2 pops will be used in this solutions. So we go back to 3,2 here, and now we will find possible directions. This is no because it is already visited, and this is no, but this is yes. So this one is 4, 3. And direction is 1, 0, 1, 2, 3. Yes, 3. And the 4, 3 will be stored here. And I am in 4, 3 now. So we will search every possible path. 0, 1, 2. Yes, 2 is yes. So last one, 4, 4 and 2 will be used. Okay, and the 4, 2, 4, 4 is stored here. Okay, this one must be inserted here. Okay. Yes, this is a final solution of this example 2 problems. And also we can modify this example 2 any ways. So example 3 can be made. If you see this one, I extended only one row more, but the solution will be quite different one. Okay, so you can practice yourself using example 3 also by yourself. Okay, that's all for the examples here. And also I want to add one last things about the size of the stack. Okay, so there are 8 directions, possible directions in these problems, and also the maze. If the given maze size is m by p maze, then we just represent m plus 2 by p plus 2 binary array. Represent the maze m by p as m plus 2 by p plus 2 binary array. How? So if this is a m by p maze problems, then we just add all boundaries as one block. Okay, and in this side also 1 1 1 1 1 1, and this side also 1 1 1 1 1 1 1 1 1, and this side also 1 1 1 1 1 1 1 1. Yes, if we surround the maze by using 1, that means that they cannot go to the outside, because every values in here, okay, this one also should be 1, this one also should be 1, and this one also should be 1, and also should be 1. So they cannot go outside of the maze, because every boundaries are filled with wall or filled with zeros. So we just use m plus 2 by p plus 2 binary array to represent m by p original maze. If we use this design, then we do not need to consider exceptional case. We must prevent going outside of the maze. But if we assume that boundary is filled with 1, then they cannot go outside because it is considered as wall. Okay, so the solution may become very simple. Okay, so it's a very good design of stack design of major size. Okay, so by using this extending only 2 row and 2 columns, the solution, the implementation becomes much more simpler than others. Okay, so this is also good design method. So you, if I make one problems, why do you use m plus 2 by p plus 2 rather than m by p maze that boundary is filled with 1? Then the solution, the answer of that question is that if we use that design, then the implementation becomes much more simpler. Okay, yes, that's all of the major problems here. So, and analysis. Okay, so the other things are just the implementations. Major search functions are implemented here and here, but we will not cover these implementations. So let's stop here. We just understand how to solve a major problem using by hand. Okay, so you must understand the algorithms to solve, and you also must understand how to represent possible directions. Okay, that's all of 3.5 sections now. Thank you today.